Problem 17 asks us to determine the domain and range for functions that are represented in different ways: data sets, tables, and graphs. At the top of the page, you see that the domain of a function is the set of all possible values for the input quantity. The range is the set of all possible values for the output quantity. Let's see how that helps us to address the questions below. Part A, we have a data set. Determine the domain of this data set. And because we have a set of ordered pairs, the domain is just going to be a list of all of the input values. And the way we do that, the way we notate that, is in a set. And we like to put set values in order from smallest to largest. So I'm going to say 2, 4, 6, 8. Those are the members of the domain set for function p of x. By the same token, the range is going to be the set of output values, and these are 3, -5, 0, and 5. We like to write them in increasing order from smallest to largest, so I'm going to start with -5, and then 0, and then 3, and then 5. Again, these curly Q brackets are important for set notation. Same idea for part B, except we have a table. We're going to list the elements of the top row as our domain. So that's our input set, 0, 2, 5, 8, and 11. Kind of an interesting looking 8 there. And for the range, we're going to list the elements in the second row, which are already in order. So 23, 54, 66, 87, and 108. Again, using those curly Q brackets. Now, in part C, we're given a graph, and we want to identify the domain. So this is going to be a little bit more challenging, but what we want to do is to start, this graph is a two-dimensional representation of the function. So what we want to do is we want to go to the starting point, and we want to map it down to the x-axis. So -4 would be the input value for this ordered pair. However, we can't actually use -4. See that that's an open circle, open value here, which means we get really close to -4 as input, but we can't actually use it. So the way we note that is just a parenthesis, -4, and then we map the last input value, which is going to be 5, and it happens to be on the horizontal axis, but it wouldn't matter where it was. So our last input value that we use is 5, and we actually do use 5. So we're going to use this interval here with a closed bracket. This is called interval notation. You're going to see different kinds of notation, interval and inequality. We're just going to do interval notation here. The range, we want to take the lowest point of our outputs, which is also -4, map that to the y-axis. So again, we're going to start at -4, but we can't use -4 because it's an open circle. So an open circle gets a parenthesis. We go from the lowest to the highest. The highest is at 4. We are actually using 4 as an output. So we put a comma there and then a closed bracket with a +4. So be sure you understand these. They're very challenging from a notation standpoint and just understanding how to break down the graph. So let's try another example and see if it helps you understand a little bit better. So for this one, the domain, we have to understand that this graph continues as far as it can go from the left on the x-axis and then all the way to the right. So all of these values are being used to generate ordered pairs on this graph. So what that means is our domain is all real numbers, which we can write this way, or as an interval, we can write it this way, negative infinity to infinity, sideways 8. Infinity and negative infinity always have open parentheses here, not the closed brackets here. Now our range is a little bit different. Again, our output values are as far negative as we can go. So we can say negative infinity for the bottom, but there is a ceiling. The ceiling is this output value right here, which corresponds to 6, and we actually are using 6 as part of our output. So here is our interval notation for our range for this graph.